Welcome, BC Fan Club, you Abyssers out there. This is the last show of the year. Yeah, I think there's a fan club. No, BC Calc. I think they're a fan of the audience.
Wow, that's true.
What if they're not like
Kruger, I feel like we should do something special for the last live stream.
If they like math, that would be wonderful.
They're just here to learn. They're not actually
Yeah.
Mr. Kruger,
I know there's a couple people out there.
It's the last live stream, so we should do something special.
Okay, like
Guys, it's David's birthday.
Dave, is it your birthday? Happy birthday to every girl and boy. We hope this very special day brings you lots of joy. We hope the birthday presents you get from mom and dad will make this very special day the best you've ever had. Happy birthday, Deva.
That's amazing.
I used to stand up on tables and do that when I was younger, but now I fall off the tables, so it's not a good thing. Alrighty. Well, you think of a finale then, Abby, as I'm going through this. Okay, you don't have to do it right now. Okay. Are we ready? So I want to review what we're doing. What we're doing is we're taking functions and we're creating power series out of them. That's the only thing we're doing. We're going to do something today that you've done before. But I'm going to do a little bit of review. This is something as BC people we should know. And so I'm going to see if this is possible. Oh, that's arctangent of x. Okay, and I'm going to take the derivative of it. Does anybody remember what it is? You want me?
Is it 1 over?
It is 1 over something.
The square root of.
Nope, no square root for tangent. What? Yep, it's got an x squared in it.
1 plus x squared. 1 minus x squared.
It has a 1 in it.
Minus.
Plus.
Hey,
Okay. Now, if you're like me and can never remember those things, I do a right triangle, and I think of this, the arctangent of x equals y, right? Some angle measurement. That means the tangent of y equals x. So here's y, here's x, and here's 1. Opposite over adjacent. Can you guys see that okay? Okay. And so then this is going to be the square root of 1 plus x squared. I take the derivative of this implicitly and get secant squared y dy dx is equal to 1. So dy dx is equal to 1 over secant squared y. And so what is secant? Secant is hypotenuse over adjacent, correct? So the secant of y is equal to the square root of 1 plus x squared. I'm going to square that, and that's where I get 1 over 1 plus x squared. Hey Maggie, how are you?
I'm good.
We're live?
Live?
Yeah, in the abyss. We're floating around. Nothing for me?
No, not today.
Okay. And Taurus, did I give you something from Mrs. Bembo? Okay. Is that a good review? Okay. And so what I'm going to do is I'm going to let f of x equals 1 over 1 plus x squared, and I'm going to determine the power series for that. Now, there's always a couple of ways to do it. You're going to find out that, remember making a Taylor polynomial? Okay, well, some of us may have been gone. So you're going to see a review of making a Taylor polynomial, and it's going to become a Taylor series because you're adding a bunch of terms, correct? You're adding a sequence of numbers. And so, but I'm not going to use that here. What I'm going to use here is I'm going to use the idea of doing a geometric power series. So that's that idea of having a over 1 minus r. And so I have to have a constant here. This number needs to be 1. So I'm going to rewrite that as 1 over 1 minus a negative x squared. That means r is now equal to a negative x squared. And that is convergent if the absolute value of r is less than 1. That means the absolute value of a negative x squared has to be less than 1 for it to be convergent. Okay? Anything bigger than 1 or 1 or greater is going to be divergent. So what I'm going to do here is I'm going to say my power series of n equals 0 to infinity is going to be a, which is 1, times a negative x squared to the n power. And that's what f of x is equal to, which is 1 plus x squared, is equal to within this interval 1 to a negative 1. Does everybody understand where I get this? I got it from here, correct? Okay, so everybody shaking their head like that's okay. All right, so this can be rewritten as a negative 1 to the nth times x to the 2n power. Oops, summation symbol. Does everybody see where this comes from and where this comes from? So that's the power series for that. And I could put in some values in here. I'll start at 0. So this would be 1, this would be 1, and I'd have 1. And if I go to a negative, it's going to be a negative x squared. If I go to 2, it's going to be positive, and it'll be plus x to the 4th. And now you can see kind of a pattern. So this is the power series expanded. This is it condensed. This is the general form. Okay? I can create another power series. This is by using the geometric, but I can also do this. I can integrate. And if I integrate this, what is its antiderivative? Yeah, the arc tangent of x. And if I integrate this, I'm going to get a power series from 0 to infinity. This is a constant, and if you remember, 2n is a constant. I'm integrating with respect to x. So because it's a power series, it always follows under the power rule. That's the advantage. So how do I integrate x to the 2n power? I do what? I increase the exponent by 1. So now it becomes 2n plus 1.
And then you divide
by that exponent, right? So that is this. And I've created a new power series for this function.
But it means the same thing.
And they mean the same thing. In fact, I'm going to use it here in a second. Okay? And when they came to this, this was really a big deal. And I'm going to show you why. All right? So what does this look like? Well, if I put 0 in here, I'm going to have 1, correct? Oh, excuse me, if I put 0 in here, I get x over 1. Is that correct? And if I put 1 in here, I'll have a negative. And then I'll have x cubed over 3. And if I put the next one, it's going to be plus x to the 5th over 5. Do you see that? So we come up with these nice patterns, don't we? Minus dot, dot, dot. Now, I'm going to put a particular number in here, and this is the part that mathematicians thought were pretty cool. They're going to put 1 in here. What?
Can you move it over?
This way, like that?
Yes.
Does that work? So I'm going to put 1 in here. And what am I putting 1 into? I'm putting it into x. So this means I'm going to have 1 over 1, which is 1, minus 1/3, plus 1/5, minus 1/7, plus 1/9, minus 1/11, plus ... Correct? Now, here's the cool part. The arctangent of 1 asks a question. What angle measurement in radians, the tangent of what, gives you 1? What?
Pi over 2.
Pi over 2, it's undefined. Pi over 4. So that means pi over 4 is equal to this. Correct?
Would it also equal the series though?
This is approximated by this. Okay? Now, that means if I multiply both sides by pi, I get 4 minus 4/3 plus 4/5 minus 4/7 plus 4/9 minus 4/11 plus 4/13 minus, and so on. So pi can be defined as the sum of an infinite series, which is a big deal. It's a different way to look at pi. Now, I went through and started computing this, not reading the fine print. Fine print says you only get within 1,000th of pi if you go like 100 of these, but eventually you get there. So that's one of the methods they use to see how accurate a computer is by using this infinite series. Does that kind of make sense?
Yeah.
Okay, that's one of the things that I think is neat. When we get to Euler's formula, that's going to be the other part. Okay? Now notice what I did here. I used the geometric power series, correct? And I used integration. I could also use derivatives to come up with another function that gives me that, and do both sides, because this will always follow the power rule, right? In other words, if I wanted to know this, I could take the derivative of this. And what is the derivative of this? It's going to be a negative 1 plus x squared to the negative 2 power times 2x, correct? That's another function, right, by taking the derivative? Well, then because this is a power series and is going to follow the power rules, if I would take the derivative of this, I would get the summation as n goes 0 to infinity, and I would have a negative 1 to the nth times n times x to the 2n minus 1, correct? Right? I would take the derivative of that, and lo and behold, I create a power series for that function. Does that make sense?
So they're all equal the same thing?
They're within an interval. Okay? Within an interval. And we're going to take a look. There are some series that for every x it works, but for this one it doesn't. You have to determine what that interval is. Yes, ma'am. They'll tell you when to do it. Okay. We're right now, that it's just a technique to create a function and tie it into an infinite series. Is that making sense? Okay. But on the BC exam, they'll say, what do you get when you integrate this series? It'll be like a multiple choice question. What do you get when you take the derivative of this series? And you just use your power rule. All right. Now I'm headed towards the notes. We okay? All right, so this is a review of Taylor and Maclaurin series. If you take a look, this is, remember, we call this a Taylor polynomial. And if I write it like this, it becomes a Taylor series because I'm adding everything. And the difference between a Taylor and a Maclaurin series, C is 0. And just a brief reminder, okay, I'm looking over here to see if that there's a thing called the Kruger series where C is 3. I'm just throwing that out there. This is the first time ever it's been stated in the abyss. Okay, and so if there's anybody else that has taken claim to that, that's too bad. So sad. Alrighty. Okay. Now, here's the other thing. So we're going to work at writing these, and hopefully it'll be a review of the Taylor series. The other thing is if the limit of the Rn term goes to 0, it means it converges to all x. F converges and is equal to f of x. They're one and the same. And we're going to look at 3 of them. So here are the guidelines for finding the Taylor series. You take the derivative of f several times. So you're going to find f of c, the first derivative of c, the second derivative of c, the third derivative of c, until you see a pattern. Okay? And hopefully the patterns will be pretty obvious. Use the sequence to develop the first step to find the coefficients. Remember, and here's the mistake I used to make, I'd forget to divide by 2 factorial, 3 factorial, n factorial. And then remember, it converges within the interval of convergence. All right? So the first one we're going to look at is sine. I gave myself a lot of room. And the first thing I notice, it's a Maclaurin series, so I write this down, c equals 0. I like c equals 0 because x minus 0 is just x, isn't it? So I'm going to write down f of 0 is equal to the sine of 0, which is equal to 0. The derivative would be what? Cosine of 0, and that's equal to 1. So I'm going to say the sine of x is equal to 1. And then I'm going to take the second derivative, and the derivative of cosine is negative sine of 0 is equal to 0. So I could write 0 plus, oh, by the way, this is going to be, I should do this. 0 plus, so this right here is f of c. And this is 1, this is f prime times x. So this is really 1 times x, isn't it? Because it's my, right? Because we start with a constant here, and then we take the first derivative, and that was the first derivative times x. Everybody with me on that? And so now I'm going to take the third derivative. I'm going to put 0 in here, and what do I get? Negative cosine of 0, which is negative 1. So it's going to be minus 1, and now I'm at the third derivative, so I got to divide by 3 factorial x to the third. This was divided by the first factorial, and this is to the first. So I'm going to go the fourth derivative of 0. And what do I get? I'm back to sine, aren't I? Sine of 0 is 0. So what do you think my next term is? It's going to be the fifth, x of the fifth, divided by 5 factorial. It's going to be a plus 1, right? Do we see a pattern yet? So that means the sine of x is equal to x minus x the third over 3 factorial plus x to the 5th over 5 factorial. What do you suppose the next one is? Minus 7th over 7 factorial. Plus, what do you suppose the next one is? X to the 9th over 9 factorial. Are we okay with that? So now we're going to write it as a power series. N equals 0 to infinity. Notice these are odd, correct? In fact, this has a 1 underneath it, right? So down here I'm going to write an odd number can be written as 2n plus 1 factorial. So I check. If I put 0 in there, do I get 1? If I put 1 in there, do I get 3? If I put 2 in there, do I get 5? It works, doesn't it? Over here, I'm going to have a negative 1.
Why is it factorial?
The bottom is
Oh,
Because
yeah,
that's the
yeah.
definition of a Taylor polynomial.
I get it.
Okay? Well, this is going to be to what power here? To the nth, correct? Because at 0 it would be 1. At 1 it'd be a negative 1. Right? And up here I'm going to have x to what power? Well, notice it's 1, 3, 5, 7, 9. It's got
2n plus 1.
2n plus 1. So I'll write a little bit nicer so our fans out there can see it better. So when I did this, and I wanted to figure out the radius of convergence, okay, I did it 2 ways. I said, well, what if I could remember, you know, what's a way I could do it? And so what I did is I did this. I did the limit as n goes to infinity of a sub n plus 1 over, this is the absolute value of a sub n, right? Remember, and if it goes to, that tells me the radius of convergence, correct? Okay, and so that's what I did at first, and I got this. X to the 2n plus 3 over 2n plus 3 factorial. Now, how did I get that? In here, I put n plus 1. In here, I put n plus 1. So when I put n plus 1 into here, I'm getting this. 2 parentheses n plus 1 plus 1. And that's where the 2n plus 3 comes from. Does that make sense? Times, over here I'm going to have 2n plus 1 factorial over x to the 2n plus 1. So, the limit as n goes to infinity, what do I get when I simplify that? Yes, n goes to infinity, not x. Thank you. So what simplifies?
You're going to get x squared
Where?
on the top.
Right, I'm going to get x squared on top. Perfect. What do I get here? So when I get stuck, you know what I do? I pick some numbers. I'm going to pick 3. I'm going to say, what do I get if n is 3? So if 3 goes into here, I would get what? 7 factorial. Would you agree? On top. Down here, if I put 3 in here, what do I get?
9.
I get 9 factorial. Right?
So it's 2 factorial.
What do I have left? I only have 2 numbers left.
9 and 8.
I get 9 and 8. That's it.
2n plus 2 and 2n plus 3.
Right, 2n plus 2 and 2n plus 3, correct? Would everybody agree with that? Right, because it goes down by ones. So I get 2n plus 3 and 2n plus 2. Right? Now, n's going to infinity. What do I get as an answer? 0. Which means this converges for every single x. Every value you put in for x here is equal to every value you put in for x here. That's what that means. It's convergent. This is my radius of convergence. Now, I could have made it a lot easier. I could have said, hey, remember that rule? If I knew what r sub n is, now what is r sub n? It's this m, which is the greatest derivative I can have, the greatest value of a derivative I can have, times x to the n plus 1 over n plus 1. Well, it's actually going to be 2n plus 1 factorial. Actually, it's going to be, this should be 3 and this should be 3. Sorry. Well, what's the greatest, since I'm talking about the sine, what's the greatest m can ever be? What's the greatest numerical derivative of sine or cosine? 1. So if I take the limit as n goes to infinity of 1 times x to the 2n plus 3 over 2n plus 3 factorial, where am I headed? 0. And if it goes to 0, that means my radius of convergence is negative infinity, less than or equal to x is less than or equal to infinity. I can do that with every single Taylor series, every single one. So I could have skipped this step. This is a step that I would use if I didn't have that rule. But because this is Taylor, that's all I have to do. So that means the sine of x is equal to this. X minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the 7th over 7 factorial plus dot, dot, dot. They're the same. Okay? Next page. Cosine. Remember this. This right here is simply telling you what a Taylor series. Again, it's Maclaurin, so it's centered around c equals 0. Okay? F of x is equal to cosine of x. So f of 0, which is always my first term in this case, will be what? 1. F prime of x, or f prime, I'll put 0 in right away. The derivative of cosine is negative sine, and negative sine of 0 is 0. So now I'm at the second derivative. And the derivative of a negative sine is negative of 0 is equal to negative 1. So I'm going to have a minus x squared over 2 factorial. because it's second derivative, exponent of 2, 2 factorial, minus 1 out front. Are we okay with that?
What?
It's this part right here. What do you think is going to happen to this one? It's going to be 0. What about the fourth one it's going to be? Plus, positive? Positive what? What's the next term? Minus what? Would you agree? It kind of looks like sine, doesn't it? Except it's shifted and it's the evens. Would you agree? So the cosine of x can be described as going from n to 0 to infinity. I got that negative 1 to the nth, correct? Here's x. What am I going to have here? I have evens now, not odds. Every even number is always divisible by 2. So down here we're going to have 2n factorial. Up here I'm going to have the 2n power. Oops, I need to do this. Are we okay with that? So r of n, which is what I'm going to take the limit of, again, the greatest derivative cosine could be is 1. And then I'm going to have x to the 2n plus 2, because that's the next number. I put in n plus 1 here and distributed the 2, over 2n plus 2 factorial. I'm going to take the limit of that, and I'm just going to write Rn, and what do I get here? Do I get 0? Yes. So that means it's convergent from negative infinity to positive infinity. That's my radius of convergence, or my interval of convergence. And so that means that cosine of x is equal to n equals 0 to infinity of a negative 1 to the nth times x to the 2n over 2n factorial, which is equal to 1 minus x squared 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, dot, dot. Making sense? I remember learning about this and things started getting tingly. There's certain times I go, oh my God, this is like really, really cool. That's when I knew I had drank the Kool-Aid. Yes?
So is this just to get it into a different form then?
Yes. Okay, because once it's in this form, okay, now we're looking at cosine. Cosine's initially defined as a ratio between two sides of a right triangle, correct? Well, now we're defining it in an algebraic sense. In algebraic sense. Now, when you take the derivative of cosine, what do you get?
Negative sign.
You get negative sine of x, right? Take the derivative of this, what do you get? 0, correct? Right?
Yeah.
Take the derivative of this, what do you get? You get a negative x, correct?
Yeah.
Take the derivative of this, what do you get? Will be x to the 3rd, correct?
Yeah.
This is 4 factorial, correct? You're going to take 4, the 4 is going to be on top, right? So the 4's cancel out, what's left? 3 factorial, correct? Then you're going to take the derivative of this, and you're going to have a minus x to the 5th over 5 factorial. Now, look at right here. Here's the sign of x. Make it negative. Make it negative. Isn't that cool?
Yeah.
So you can define what the derivative of cosine is by using your power series to do it. All right? All right, next one. We're almost there. E of the x. Now, what do you know about every derivative of e of the x? And if it's Maclaurin and c equals 0, they're all going to have x in them, correct? And when you plug in 0 into e of the x, right, it'll be e of the 0. What's the derivative at 0? 1 for every single one, correct? So that means e of the x is going to be 1 plus 1x plus 1x squared over 2 factorial plus 1x cubed over 3 factorial plus x to the 4th, or there's a 1 here, 4 factorial plus dot, 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 right? These are the derivatives. That's why I'm writing them down. So that means e of the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot, dot, dot. Correct? Doesn't it kind of look like it's possible that sine and cosine are kind of in there? They're real similar in some sense, right?
Is it sine of x plus cosine?
Well, we're going to see in a second, okay? So, what's r of n? Oh, first of all, this is defined as what? I got to do this. E of the x is equal this, n equals 0 to infinity of what? Well, is it going to be a negative 1?
No.
No.
1 over
X to what power?
n.
N over what?
N factorial.
N factorial. Right?
And within that, because 0 factorial is 1.
Okay, now. Oops, I gotta get to the right page. I'm on the wrong page, sorry. So, what is this going to be? Well, m is going to be the maximum derivative of e of the x, correct? Well, what's the problem? E of the x keeps getting
Bigger.
bigger. Okay, and I'll show you how we're going to deal with that. This is going to be x to the n plus 1. This is going to be n plus 1 infinity, correct? I mean factorial. Why did I say infinity? I meant factorial. Yep.
What does R of n mean?
R of n is the remaining sums in the series.
Okay.
So if I would have stopped here, R of n is the rest of them.
Okay.
Okay? And they diminish as we go on. So this is going to be a humongous number, correct? And so this is going to be e, and I'm going to call it, because this is, my derivative is always e of the x, right? So some z in there is going to give me that derivative. And here I'm going to have x to the n plus 1, and I'm going to take the limit. Now here's the thing you got to remember. The only thing that's changing is n, isn't it? Correct? This is a constant, and this is getting bigger, right? But this will, you pick some x and make it 4, but this gets bigger than 4 raised to a power. Would you agree? Because if you pick 4, well, you're also going to be multiplying. That means 4 is going to be multiplied by itself n plus 1 times, right? But you got 100 times 99 times 98 times 97 that are all bigger than 4. So this is going to be headed to 0.
So what is the
But isn't it multiplied by infinity on the top?
Z says, all right, pick some number. Okay, a billion, e to the billionth. Okay, now it's constant, isn't it?
Okay.
We'll now have a billion factorial. Well, billion factorial is a lot bigger than e to the billionth power, because that means you're multiplying 2.718 a billion times itself a billion times, right? But you're going to take a billion, which is bigger than 2.718, times 1 less than a billion, then 2 less than a billion. You understand what I mean? This is going to 0. So that means e to the x is the same as this.
What happens if you don't get 0 for that one?
That means it converges in that ratio. Okay, and that's where you go to the limit of an plus 1 over a of n, and you look at that. And I did that on here. In fact, I'll show you right here where it is. I did it last year. So here I said this was what a sub n is. Here's where the next one is. I created this ratio. It simplifies to this. I think it's easier to see when you do it in using the ratio test, and it goes to 0. Okay, so I included that. But here's another way to look at it. Does that help? Okay.
And what's z? Like, where did you get the
Z is some number between negative infinity to infinity. You pick it. Okay, I'll pick a billion. E to the billion is a huge number.
So m is e to the z.
M is the e to the z, correct.
Okay. That's
It's the biggest derivative you can get in the interval.
okay.
Well, it gets huge, doesn't it? But it's never going to be bigger than n plus 1 factorial. And that's why I brought that up. Okay? It's, to me, that's the most heaviest part. That's why I think this is a lot easier to see right here. Okay? Alrighty. Now, this converges here. Correct? Right?
Yeah.
Which means I can put anything into e to the x and do this. Correct? Anything I want. Right? Okay. I'm going to pick e to the pi.
Oh God, no.
Oh, that's e to the I pi.
Okay? I get to pick it. And since this is my last day lecturing, I choose to pick that. I pi.
Why I pi?
You'll find out a little bit.
Oh, it's the equation on the board.
Okay? Well, what does that mean? This is equal to 1. Now remember, it's up here, right? You can see it? Plus I pi plus I pi squared over 2 factorial plus I pi cubed over 3 factorial plus I pi to the 4th over 4 factorial plus, this is getting a little redundant, I'm getting a little tired, 5 over 5 factorial. Oh, what the heck, I'll do it one more time. Dot, dot, dot. Correct? Yes, sir.
So, how do you know I can go in for x?
Because all of infinity. And the complex numbers are infinity. The reals are just members of the complex numbers. I just want to take a moment and go into the realm of complex numbers.
Right. So that exists in that.
Yeah. It belongs in reals, correct? Right?
Does
E, the x belongs in reals, right? Okay. And so if I can create e, if e to the x belongs to the subset, well, then it must belong to the big family, right? I belong to the Ernst family, which is a humongous family, even though the Krugers are just a small subset.
Uncle what?
Okay? My mother's maiden name is Ernst.
Ernst?
Yeah, Ernst. E-R-N-S-T, Ernst. Okay?
Bigger than the Kruger family.
Oh, yeah. A lot of Krugers die young.
Oh.
Okay. Alrighty, we ready? Now, I to the first is I. Do you remember that? What's I to the second?
1.
Nope.
-1.
Negative 1.
Ah.
What's I to the third?
I.
Negative I. We're getting there. I to the fourth.
I.
1. Did you guys ever learn that?
Yes.
Okay. So I to the fifth is what? I. I to the sixth. -1. Okay? So, e to the I pi equals 1 plus I pi minus pi, minus I pi. Oh no, I'm squaring it, sorry. I gotta make sure I do this right. Minus pi squared over 2 factorial. Minus I pi cubed over 3 factorial. Plus pi to the fourth over 4 factorial. Plus I pi to the fifth over 5 factorial. Minus pi to the sixth over 6 factorial. Minus I pi to the seventh over 7 factorial. And I'll do this last one, plus pi to the eighth over 8 factorial. Plus dot, 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 dot. Okay? So now I'm going to regroup them. And I'm going to have this. I'm going to put a parentheses here. I'm going to take 1, and I'm going to take a negative pi squared over 2 factorial. And I'm going to take plus pi to the fourth over 4 factorial. I'm going to take a minus pi to the sixth over 6 factorial. So I took this one. I'm taking the non-I ones. I'll take this last one too. Plus pi to the eighth over 8 factorial.
Why are you just taking the non-I?
I'm going to show you in a second. And then I have these, the I ones. What do I have here? I have I pi, and then I have a minus I pi cubed over 3 factorial. I have a plus I pi to the fifth over 5 factorial. I have a minus I to the pi to the seventh over 7 factorial plus dot, 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 parentheses. I'm going to do one more step here. E to the I pi equals, and I have 1 minus pi squared over 2 factorial plus pi to the fourth over 4 factorial minus pi to the sixth over 6 factorial plus pi to the eighth over 8 factorial minus dot, dot, dot. And I'm going to factor out an I here since they all have I's in them. And I'm going to be left with pi minus pi cubed over 3 factorial plus pi to the fifth over 5 factorial minus pi to the seventh over 7 factorial plus dot, dot, dot there. All right. Take a break. Breathe heavily. Now, have you seen this before? Did it look like something like?
Is it? You're lying.
Oh, I thought you were gonna walk out. And then you got to walk out and you're like, I'm done. Okay,
I've been gone for 2 weeks and I come back to this.
okay, you're right.
This is a great last lesson, Kruger. This is nuts.
Do you see this?
Yes, except X is now pi.
So this is what?
Oh, my land.
It's the what?
Sine of
Cosine of what?
Cosine of pi,
Cosine of pi.
which is equal to
Plus,
0
this is I times what?
minus 1.
What is this? I times 1. Sine of what in it? Pi.
Oh, my Lanta.
What's the cosine of pi?
Oh my god. Think of one.
1.
What's the sine of pi?
Wait, why is the cosine of pi negative?
It always has been.
Because it's
Oh,
0.
sorry, I spaced out for a second.
Okay, that's all
I was
right.
thinking of 0.
because that's what it is.
It's 0.
Plus, what's the sine of pi?
Whoops.
Dave is out of here.
That means e to the I pi plus 1 equals 0. Hallelujah! Hallelujah! Hallelujah!
You stop.
Woo!
E to the I pi equals negative 1.
All that work to get this beautiful little tiny
Okay, but
equation.
does that mean?
That means this equation has every branch of mathematics in it.
Stop. What about geometry?
Right here.
So-
Pi is initially defined as a geometrical part.
So every single thing that you can think of goes into there?
Yep.
So if I
The,
do like,
the addition identity, the multiplication identity, E, which comes from analysis, and I, the imaginary number. All the important numbers that math actually cares about. We don't give a hoot about a mole.
Okay, neither do I.
And I know Mr. Stock can find that in the abyss, but what the heck. Okay.
What?
Does that make sense?
no, but I understand.
Yeah, mic off the table. Mic drop.
I think that's so cool.
It's live. Go back and watch it right now, Sean.
This frog has found his.
All right, you ready?
Is that it?
Oh, it's
Okay,
not
can I
printed.
go to the next page of the notes?
We have. More than
5.
Oh, we are like out of here in like
We have like 2 minutes.
2 minutes. Can I point something out?
Yes.
Okay.
yeah.
I'm going to skip example 4 right now, but
Are we going to continue the notes tomorrow?
yeah, we'll finish the notes tomorrow.
Wait, whoa. So today's not the last day of streaming?
Tomorrow will be the last day.
Okay.
Okay. Well, okay.
Time to
Okay.
plan something.
I had to get to my moment, so that gives you a little bit more time to get to your moment, since tomorrow will be the official last day.
All right,
Is that
I'm
fair?
taking snaps
So now you
off
guys
the
can
table.
think of something. I'm a little nervous by actually saying that, but I trust you. Okay? You wouldn't do anything. Okay, you wouldn't do anything more embarrassing than what I do up
Can I
here,
pull
right?
out my phone? 2, 3. Oh, when we're done.
Yeah, when you're done. Can I just point this out?
Yes.
Okay, so these are functions and their power series. And over here, the interval of convergence. They're expecting that you have cosine memorized, sine memorized, e to the x memorized. To me, e to the x is the easiest. Sine and cosine are very similar. I've always thought sine is a little odd and cosine is a little even.
What do you mean by that? What, are you trying to make a joke?
No, it's a little memory clue in which because I had to know them, so I always thought cosine is even and sine is odd.
Crazy.
Okay, even though I pronounce this cos and this sin. Okay. The other one they want you to know is you really should know those 3 for sure. Okay, those will be a multiple choice sections of the BC. All right. Okay.
So do you need to know like the general form of the power series?
Right. Yep. You should be able to put the, well, they give you the general form at the very end. Do you see that?
Yep.
On this, and I will give you this handout tomorrow. I have 2 handouts I'm going to give you, and this will be one of them. Okay?
Okay.
Yes.
So since we have to finish the notes tomorrow, are we gonna move the review till Friday? Or
Yep.
Okay.
So test Monday?
Yep.
Maybe that means I can take it with you guys. That means.
That means I have 3 very large tests.
On Monday I have 2 grad tests.
Oh.
Psych.
Okay. This will be a real quick test. Be like.
So do you have a count? Do you have a
All right.
do you
We're
have-
signing off. See you tomorrow.
Bye.
You don't